This reaction seems like your standard SN2 reaction. We have a good nucleophile, and the substrate is a primary alkyl halide, so a good leaving group. But it turns out there's also an acidic proton in the molecule. And because the fastest reaction that can occur, remember acid-base chemistry was kinetic reaction, a kinetic process. And so that means that's the first reaction that we'll see happen. So the sodium hydroxide will actually act as a base and remove the proton, leaving the electrons on the oxygen. So we'll get this intermediate. And so now I have another nucleophile. So my job here is going to be to keep track of if I have a good nucleophile and a leaving group, and it's even in the same molecule, I should probably start numbering off the carbons, the positions, because I'm going to actually have a reaction occur intramolecularly. So that negative charge will attack the carbon with the leaving group as expected now, but it's within the molecule. So our leaving group leaves, and that should give us a 6-membered ring. Actually, only 5. You can tell by the count I just did. So I'm going to make my 5-membered ring, and then I'm going to go back and count things. That's position 1. Position 2 has a methyl group on it. You can see from this position here. So we'll put the methyl group on. Oops, wrong position. Position 2. And then position 3 doesn't have anything. There's position 3, position 4, position 5. Position 4 also has a methyl group. So we'll add that right here. And there's your product. There's a stray mark I'll erase. Note that there are some other bases that could do this kind of thing, where they first remove a proton to make a nucleophile of the molecule, whether it's intramolecular or not. So sodium hydride is another prime base. This base delivers H-, and so that can also be a nucleophile, or a base for the reaction to remove a proton.